Hi, everyone. Let's take a look at number 17 on page 387. Communication. A judge in a model airplane contest says the probability of a model landing without damage is 0.798. So there's only one chance in five that any of the seven models in the finals will be damaged. Discuss the accuracy of the judge's statement. Step one, let's write down the let statement. Let X be the number of model, or you can say model airplanes that will be damaged. Now, your goal is to compare two numbers. Your goal really, and I'll put this in a thought process, you're trying to find out if the probability of x greater than 0, is that going to be greater than, is that going to be equal to, or is that going to be less than the second number, which is given in the question here, one chance in five. So for your reference, one chance in five, of course, is 1 divided by 5, or as a decimal, 0.20. So your goal again is to compare these two numbers to figure out what is true. So let's go back. Again, you can tell by the given, this is a binomial distribution. How do we know that? Anytime there's any type of success and failure, that signals to you there are two values, P and Q. So again, in this context, we have 0.798, which is what happens when the model is landing without damage. So we're going to define that as Q, which is 0.798. So the opposite of that, which is P, which equals to 1 minus Q, is going to be 0.202. Let me just double check my mental math. And I'm just basically adding P and Q, which must add up to 1. So again, I'm just doing this live with you. P plus Q is going to be 1. Right, that makes sense. So now we're ready to solve this. Now, again, there are two ways of solving this question. The first method is called the direct method. Second one's the indirect method. My favorite method, just because on average, indirect method is a little bit faster. So the goal here is to find P of x greater than 0. And by thinking about it from an indirect method perspective, that's going to be 1, which is 100%, all combinations, minus P of 0, or x equal to 0, if you will. So I'm taking all the combinations minus the opposite of what we're looking for. So in this case, it's going to be 1 minus. And again, if I think about the binomial distribution one more time, it's going to be n choose x times p to the power of x times q to the power of n minus x. That's the general idea behind the binomial distribution. So in this case, it's going to be 7, which is n, because it says right here, there are 7 models. So this 7 came from 7 models. 7 choose none of them because x is going to be 0. So 7 choose 0 times p, which is going to be 0.202 to the power of 0, times q, which is 0.798 to the power of 7 minus 0, which is 7. Now, at this point, grab a calculator. I'm going to grab mine. Let's work it out. In the display, I see 0.7939274053. I can round this to 2 decimals. So it's going to be approximately 0.79. And again, feel free to round to 4 decimals, 2 decimals, whatever fits the question that you're thinking about. And if you think about this, this is definitely greater than 0.2. So this means, and again, I'll say the final statement running out of space, but I would love to say this and you can write it down. Therefore, the probability that at least one model will be damaged is 0.79, which is greater than one chance in 5. If you find this video meaningful as adding value to your math life, please comment, share, like, and subscribe. I hope this makes sense.